Alright, today's lesson is on significant figures, usually just called sig figs. To kind of help me out a little bit, explain what sig figs are first, I print off some notes from chemistry just to lay down and take a look at here. Significant figures, and there's a definition of it, or what have you, and even the reason why we do significant figures, and if you want to read that, I'll let you read that. But anyway, how to actually do it, which is what most of you watching this would be interested in. The only thing you got to pay any attention to when you're doing sig figs or counting sig figs are zeros. And it's really very easy, and I don't know why people have so much trouble with it. All you have to do is pay attention to this. Zeros that come at the end of a number, and I think technically you call these terminal zeros, but anyway, zeros that come at the end of a number without a decimal place do not count. So like here in the number 20, that zero doesn't count. The only way zeros at the end of the number count, or terminal zeros, is if there's a decimal somewhere in that number. So like in the number 20, that zero doesn't count. It's at the end. There is no decimal. So this one just has one sig fig in that number. Now, if I were to have placed a decimal in that number, like make this 2.0, that zeros count. So you'd say 2. If I put the decimal in front of the 2, that counts. You would now call it 2 sig figs. The number 1200, these zeros do not count because there is no decimal. So the 1 and the 2 count. So we would say that there are 2 sig figs in that number. Now if I put a decimal between the 1 and the 2, the zeros count. If I put a decimal between the 2 and the 0, called it 12.00, you'd say 4 sig figs. If I put the decimal here and made this 120.0, you would call it 4 sig figs. If I put the decimal in front of the 1, made it 0.1200, there would be 4 sig figs. Now this 0 you don't even have to worry about. It's between the 1 and the 2 that makes it count. The 0 on the end does not count because there is no decimal. So this one has 3 sig figs when we do it. Now this is even easier. Zeros that come at the beginning of a number, they're just holding the decimal place. They never count. See if I can write that in big letters. You never count zeros that come at the beginning of a number. So like 0.2, that 0 does not count. So you would say 1 sig fig. Here, 0.012, zeros at the beginning never count. So you would call that 2 sig figs in that one. Over here, once again, it don't matter if there's 20 zeros at the beginning of this number. 0.00000000000. Those zeros would not count. So here, these zeros at the beginning of this number, they do not count. Get rid of all of them. The 2 counts, and this 0 doesn't count. Yes, because there was a decimal in the number. If there's a decimal in the number, the 0 then counts. So this was 0.0020. So these zeros did not count, but this 0 did because of the decimal. So this one has 2 sig figs in it. Alright, so let's take a look at these examples. The number 5 just has 1 sig fig. The number 50, here, 5 and a 0, but there's no decimal, so that 0 doesn't count, so that's 1 sig fig. Here, technically this is weird, but 50 point, technically we could call that 2 sig figs, but usually if you had this number, someone would probably move the decimal 1 and make it 5.0 times 10 to the 1. It would look a little bit more normal. Here, 50.0, how many? 3, very good. We say 3. Both these zeros count because of the decimal. Here, 5040. The 0 on the end doesn't count because there's no decimal. So this 0, no brainer, it counts. It's between 2 numbers. If you see a 0 between 2 numbers, you don't even have to worry about it. So this one has 3 sig figs. This one over here, this 0 is between 2 numbers. This 0 is between 2 numbers. The 0 on the end is a question. but because there's a decimal, it counts. So you've got a total of 7 sig figs in this one. This one, zeros at the beginning never count, ever. So this one is just 1 sig fig. Here, zeros at the beginning, once again, never count. The 0 on the end, does it count? Yes, because of that decimal. So the 4 and the 0, you have 2 sig figs. Come over here. Zeros at the beginning never count. So none of those zeros count. The 2 counts. This 0 is between two numbers, so it counts. So we've got 2, 0, 1. You've got 3 sig figs in this one. Alright. In this one, look at all these zeros. 0.00000. Zeros at the beginning, once again, never count. So this one only has 1 sig fig in the problem. Now, a lot of the college homework stuff all makes you do everything in sig figs. So let's do a little bit more sig figs. Technically, there's 2 rules for doing sig figs. I got blood on my paper. Anyway, technically, there's 2 rules for doing sig figs. We'll go through both of those real quick. You've got one is the multiplying or the dividing rule. So when you multiply and divide, you do one rule. To do multiplying and dividing, you go by your least number of sig figs. So you look at all your numbers. Your answer can have no more sig figs than the least you were given. Now, this doesn't mean don't count, like if you're working a problem and you're going to use 12 inches per 1 foot in the problem. This 12 is like an absolute 12. So it's like 12.0000. So this one, you don't count this one. So when you're doing your sig figs, you don't count like 1,000 milliliters per liter. You don't count that in your sig figs. So don't count things that are like absolute values and numbers. I was trying to sit here and think of some more off the top of my head, but hopefully you kind of get the idea in that. Alright, so when you're doing something like this, I'm trying to think of an example. Let's say that you had 2.0 times 1,450 divided by, divided by 1.520 is equal to, we can take our calculator, 2 times 1450 divided by 1.520. And the calculator, look at that big long strand of numbers. The calculator says 1,907.894737. Now we would not go with all those numbers. You have to go with your least number of sig figs. So in this problem, your least sig figs. This number here has got 4 sig figs. This number has got 3 sig figs. 2.0 is 2 sig figs. So your answer can only have 2 sig figs in it. So that means we keep the 9, we keep the 9. It doesn't round. So this answer rounds to, and this is where some people are goofy and they'll write 19. Y'all, if you round, man, you can tell I'm Southern in this video now, can't you? If you round 1907.8 down to 19, you do not know how to round. We're rounding this number off to 1900 because that is 2 sig figs. These 2 zeros do not count. So you've got 1 and 9. Your answer is 1900. So that's how you do sig figs for multiplying and dividing. You look at everything and you do your least. We could do another one like this. We could have, let's go with 5 times 17.2 divided by 4.1 equals. You go to put in your calculator. We got 5 times 17.2 divided by 4.1. 20.9756. 20.9756. We'll round off. 2 sig figs, 3 sig figs, 1. Your answer can only have 1 sig fig. So if you looked at this and rounded it to 21, you just gave it 2 sig figs. So that would be wrong. Your answer is just going to be 20. No decimal place. If you put a decimal in here, you're going to be getting more than one significant figure. The number 20 has 1 sig fig, just like this problem only had 1 sig fig. That's how you round off doing your sig figs with multiplying and dividing. Now, there is a second sig fig rule. The second rule is for adding and subtracting. So we'll have our second rule. We'll call it rule number 2. Rule number 2 is for adding or subtracting. The rule for adding and subtracting is decimal places. Well, I should have said you use the least number of decimal places. This one's really very easy. All you have to do is go by your least number of decimal places. So say, for example, you had the number 5.0, 14.91, and let's go with 2.031. And you were going to add these numbers together. Your answer would be 1, 4, 9, 9, 10, 11, carry 1. Your answer would be 29.4941. You go by the least decimal places. This one has 1 decimal place, 2 decimal place, or 3 decimal place. Well, your answer can only have 1 decimal place. We aren't even counting our sig figs. All we're doing is decimal places. Here you've got 1 decimal place, so our answer, I'll keep 1 decimal. So this answer is 21.9. That's all my answer is. So for a second example, let's say that we had 3 plus 2.41 plus 8.3. If that was what we had, 3 plus 2.41 plus 8.3 equals 13.71. Here, I've got no decimal place though. So if I've got no decimal place, my answer can't have a decimal in it. So this answer, 13.71, becomes 14. Rounded off, no decimal place. That's how you do your adding and subtracting rule. And hopefully this will kind of get you started on your significant figures. I'm going to take a couple of looks at examples from my survey text now for class. This is one of my examples. Example B, uncertainty in measurement. A carpet is being installed in a room. It's 12.71 in width, 3.46 across. What is the area of the room? So I've got a rug in or a room in this problem. They're putting in carpet. I'm obviously not drawing it to scale. I just messed that up. But anyway, 3.46 meters by 12.71 meters. What is the area of the room? So multiply length times width for area, and I get 3.46 times 12.71, and that's 43.9766 meters squared. Well, this has 3 sig figs, this one has 4. So my answer can only have 3 sig figs. So I'm going to go in here, 4, 3, 9, but the 7 rounds the 9 off, so this becomes 44.0 meters squared for my sig figs in this problem. Alright. That's my only example. So thank you and good luck.